All right, I'm getting started right now. Okay, so we're in 1-1 of Algebra 2, which is patterns and expressions. Hopefully a lot of this stuff will be familiar to you guys that we go through it. So when we get started, page 4. Problem 1, page 4, and anybody that hasn't had these types of books before, which is probably most of you, is it's the example problems they call problems, right? So if I say problem 1, I'm not talking about the actual homework problems. I'm talking about an example problem on page 4. So here, we're looking at the figures from left to right, and that's, starting on the left, heading to the right. And we want to discover the pattern, tell what the pattern is, and then say what the next figure is going to look like. So we started off with a triangle, square, pentagon, hexagon. What's going to be the next one in here? Let's ask Christian. A seven-sided figure, which has two different names, right? What's one name? A seven-gon is one, right? That's a good one to know if you can't remember the names, right? Seven-gon. The other one is heptagon, H-E-P. All right, so it's got two names, seven-gon and heptagon, right? Huh? 9. And I can draw perfect heptagons, right? There you go. That's a perfect heptagon, right? 7 sides on it. It looks really good. Right? So this is identifying pattern, right? We saw something that was reoccurring. We predicted the next one in the sequence. Right. Let's go ahead. I'm going to use the curtain on this. All right. So we have some definition here. One is variable, which we used a lot in Algebra 1 and then quite a bit in geometry. The variable is a symbol that is just a placeholder. It's just instead of knowing the number, if you don't know the number, you put in this placeholder and it just holds the spot until you get the actual number. A lot of times we use letters for it, like X, right? X is the most popular one. But it could really just be anything, right? 'Cause it's just a placeholder. You could use a question mark if you wanted to, but I think making an X is a little bit easier than making a question mark. But yeah, you could use anything. You could use a squiggly line, so long as it's just it's a placeholder. So there's no meaning behind the specific letter you use other than it's just holding the place. Right. And then we have two different types of expression. One is numerical expression, and this is a math phrase, right? Math phrase with no variables. So on the side over there, I have 3 plus 5, or like parentheses 8 minus 2 and parentheses plus 5, right? No variables in those, right? So those are numerical. And if you look at numerical, what's numerical look like? What word does it remind you of? Number, which makes sense because if you only have numbers, right? Numbers and operations. So that makes sense. The next one's going to be algebraic expression. Now, what does algebraic look like? Algebra. Algebra has numbers and operations, but it also has variables, and that's the key difference here. Algebraic has variables in it. So if you look on the side there, we have expressions that look similar, but one's algebraic, and the ones above it are numerical. So we have 3n plus 5, or parentheses 8x minus 2, parentheses plus 5n. Okay, so those are the difference between numerical and algebraic. As we get going in this class, most of the stuff we're going to be doing is algebraic, and we won't really even be calling them algebraic. We'll just say, hey, it's an expression, and we'll automatically know it's an algebraic one. All right. This is problem 2 on page 5. We have a pattern of toothpicks. Now, I think in the book it actually gives you a nicer looking toothpicks than mine. Mine are just boxes. But start off with 1 box of toothpicks, and then 2 boxes, and 3 boxes. Well, what we want to do is we want to discover the pattern and then come up with the 20th figure. Now, we could do this by drawing 20 of them, right? but that's a little bit more difficult. So what we're going to do is we're going to try to come up with a rule or an equation to figure it out. Did you already have it? Yeah, that's it. We're going to have times by 4. But let's see y first, so then when they get more complicated, we can understand it, okay? So if I look at figure 1, right? Figure 1 is this one right here. We have one box, and we have 4 toothpicks, right? So I'm going to have 4 toothpicks. But if we think about it, each box has how many toothpicks? 4, right? So if I have one box, we'll multiply that by 4 to get my total toothpicks. Then here at 2, we have 2 times 4. Right? Two boxes of toothpicks, 4 toothpicks per box, gives us 8. Then 3 times 4 gives us 12. And then down on the bottom, finally, we have n, right? It's a placeholder because if we want to keep the variable in there. So we're going to have, what's our math going to look like? N times 4, and the way that we like to see it is 4n, right? That's the way it's more normal for us. So 4n, right? And number of toothpicks, well, that's still going to just be 4n because of n's a placeholder, right? We can't do anything with it until we know what n's supposed to be. But what do we want n to be? All right, what did the question ask for? 20, right? So we want to know at the 20th figure. So I'm going to plug in 20, right? That's a placeholder until I know I want 20. I'm just going to do my math over on the side here. I'm going to have 4 times 20, and that is 80. So you're going to need 80 toothpicks. Right? Not so bad, right? All right, here. Oh, I have problem 3. And it's talking about aquariums with fish inside there. Now, if you have an aquarium, you know that you can't just stick as many fish will fit in there because they have to swim around and live and stuff like that, right? So they usually come up with some type of graph or rule saying how many fish you can have in there. So, or how many gallons you need per fish. So if on the bottom of this graph, if I have inches of fish, right, which makes sense because if you have a bigger fish, it's going to need more space. And then over on the y-axis, I have gallons of water. Right? We can figure out how big gallon do we need. So we want to buy 5 2-inch platies, 4 1-inch guppies, and a 3-inch loach. And it wants to know what's the smallest tank we can buy, 15, 20, or 25 gallons. Okay. So we're going to have to do a few things. One is count up the total inches of fish that we have, and then we're going to have to look at the graph and try to come up with a good estimate. Okay. So we have, let's see here, we have 5 2-inch platies, that's 10 inches, right? 4 1-inch guppies is 4, and then a 3-inch loach, which gives us how many inches? 17. Right? 17 inches of fish. So from here, what we need to do is look at the graph and see if we can come up with a pattern in order to come up with how big of our fish tank is going to be. Does anybody see the pattern at all? Well, let's use a few, okay? This will be inches, right? Inches, and that'll be our input. So let's look at the graph and somebody pick out a number of inches of fish. Doesn't matter. That's it? Did somebody say 6? Why not? All right, 6 inches. So if we have 6 inches of fish, how big is our gallons going to be? What's our output? Well, let's look at 6. All right, 6 is here. How big of a tank do you need? 8 gallons. All right, so that would be my output. Okay, now let's use another amount other than 6? 7. How about 7? So 7, if I look at 7, I go up, it's 9. And one more just for fun. 8, okay? 8 is 10. So 8 inches of fish need 10 gallons of water. Now, if I look in the process one and I want to make up a algebra or an expression in there to represent what's happening, what math are we doing to get from the inches of fish to the gallons of water? Yeah, adding 2, right? So here it's going to be 6 plus 2, 7 plus 2, 8 plus 2. And then if I have n, a variable n, what's the process going to be? N plus 2. Right? And then the output will just depend on what input you use. So what's my input number that I'm going to use? 17, because that's what I know, right? So that's my number of my inches of fish. So I'm going to put in 17. So instead of using n plus 2, I'm going to use 17 plus 2. And that gives me what as an answer? 19. So knowing this, what's the smallest tank size I can buy? People that say 20 are right. People that say 15 are wrong, because if you use 15, that's going to be too small, right? 15 is smaller than 19. The fish need at least 19, right? So you can't cut it down to 15. So they need 20. It's always nice to give the fish a little bit more room than to keep them crowded, right? That is all for today. It's just patterns and then coming up with your rule or your process like we did here, okay? So homework assignments on page 7, 9 through 23 odd, and then 25 through 39, that one's all. It's always a problem, all right? All right, well, have good luck.